Hey, what's going on? It's Justin Dickmeyer from EngineerInTrainingMA, and in this video we're going to review matrix algebra, and more specifically the transpose and determinant of a matrix. So what is the transpose of a matrix? The transpose of one matrix is another matrix obtained by using the rows from the first original matrix as columns in the second matrix. This new transposed matrix is represented using the identity of the original matrix. So if it's matrix A, we use the letter A followed by a prime symbol. So A, the transpose of A would be A prime. So let's illustrate this real quick. It's a fairly simple concept here, but let's say that we have matrix A and it has the elements 0, 1, 3, 7, 4, 10. So to get the transpose of matrix A, we need to use the rows as columns in the new matrix. So row number 1 is 0, 1. That's going to be column 1 in our transposed matrix. So 0, 1. The second row is 3, 7, which is the second column over here, 3, 7, and then 4, 10. And that's essentially it. So just note, I know you guys can see, but a 3 by 2 matrix, when transposed, becomes a 2 by 3 matrix, so it's essentially flipped on its side. So what about the determinant of a matrix? What is the determinant, and what does that mean? Well, the determinant is a unique number associated with a square matrix. So we're dealing with n by n square matrices here. Now there are two ways that you may see a determinant represented. For the first one is, say we have a matrix A. The determinant can be represented as A and between some square brackets right there. Or it can be represented as determinant, or DET of A. Now these terms right here are interchangeable and they mean exactly the same thing. So let's start finding the determinant of matrices. Like I said, they're unique real numbers associated with a square matrix. So let's look at the 2 by 2 matrix, say matrix A, that has the terms A, B, C, D. So to find the determinant of this matrix, all we need to do is multiply A times D minus B times C. And so that will give us some number, and that will be considered the determinant of that 2 by 2 matrix. So it's A times D minus B times C. So let's look at some real numbers here. Let's say we have a matrix with the elements 1, 2, 3, 4. Now the determinant of A would be 1 times 4 minus 2 times 3. And that equals -2. So what about 3 by 3 matrices? Well, the work involved in finding the determinant of a 3 by 3 matrix is a little bit more complicated, a little bit more involved, but it's not really all that hard. It's just a simple process. What we do is we take our 3 by 3 matrix and break it down into a series of 2 by 2 matrices multiplied by some scalar. So let's illustrate this using an example, because that's probably will help you guys understand it the best. Let's say we're given a 3 by 3 matrix with the values or the elements 2, 1, 3, 5, 6, 9, 8, 1, 1. So what we want to do is break this matrix down into a series of smaller 2 by 2 matrices multiplied by a scalar. So what we do is we choose one of our rows that we want to be the scalar row, and we're just going to choose this top row. This is the process the way I go about finding the determinant of a 3 by 3 matrix. So let's choose our top row as the scalar row. So what we do is we take the first value 2, And so what we do is we ignore all the values that are in that row, and all the values that are in the column of that number. And that leaves us with 4 values, 6, 9, 1, 1, or I should call them elements. Leaves us with 4 elements, 6, 9, 1, 1. And that becomes our matrix. So what we do is we take our scalar value 2 and set it as a product against the matrix 6, 9, 1, 1. Now we just run through the same process working left to right. We choose now 1 as our scalar. Pretend these lines aren't here. And what we do is ignore the row and we ignore the column now. And so we have our scalar 1 and the new matrix 5, 9, 8, 1. And then finally we have, let's take 3 as our scalar. And we ignore, once again, the row, and we ignore the column numbers that scalar is in. And that leaves us with the matrix 5, 6, 8, 1. So it's important to note that when you're taking the determinant of a 3x3 matrix, that the signs in front of the scalars alternate. So we have a plus here, minus, plus. So that's important. It's not adding them all together. It's plus, minus, plus. And we can go through a whole proof of that, but there's no time to do that on the test. Just remember that. So all we need to do now is use our general form for finding the determinant of a 2x2 matrix, which is A times D minus B times C. For each one of these, add them up, and that's our determinant. So what we get is the determinant of A is equal to 2 times negative 3 minus 1 times negative 67 plus 3 minus 43, which ends up being the determinant of A is equal to negative 68. So that's essentially it. You just take that 3x3 matrix, break it down into a series of 2x2 matrices multiplied by a scalar, and you guys should be all good to go. And it's a basic process. If you do this a couple times, it'll pretty much become automatic. And that's it. So if you guys want to, head on over to EngineerInTrainingMA.com and leave me some feedback, through the contact form, or sign up for my free EIT preparation boot camp and get set on the right foot as you guys begin your journey. But either way, I'll continue to provide you guys with the best value that I can through these videos. So any feedback or any suggestions is definitely appreciated. So you guys take care. We'll be talking soon. All right, bye.